The next three lessons are all different patterns that you might find as you are factoring. The first of those is the perfect square trinomial. In the perfect square trinomial, it's called that because when we factor it, it factors into the same binomial 2 times, and so we can write it as that binomial squared. In order for it to be a perfect square trinomial pattern, you have to have the first and last terms be perfect squares, and the middle term must equal twice the product of those two. So this doesn't really make sense until you actually do a question. I've kept that at the bottom of each of your slides so that you can see it as we go through. So let's look at this first one. Notice that my first term is a perfect square because I can take the square root of it and get x. And my last term is a perfect square because I can take the square root and get 4, because 4 times 4 is 16. Then we check our middle term. So our middle term must equal twice the product of the expressions. So x and 4, their product would be 4x. And if I doubled it, if I took twice that product, I would get 8x, which is what I have as my middle term. So because it fits this description, I'm going to use my perfect square factoring formula that says it's those two values with a plus in between. So my factorization of x squared plus 8x plus 16 is x plus 4 quantity squared. Now let's say I didn't see that pattern and I just factored it as normal. I would have said what are numbers that multiply to 16 that add to 8, and that would be positive 4 and positive 4. So I would have written it as x plus 4, x plus 4, and then of course that is the same answer as x plus 4 quantity squared. So this is just a pattern that might be helpful for you, but it's not necessary. On this example, again, there's no GCF that I could take out of everything, but I can say that the square root of 9x to the 4th is 3x squared, and the square root of 25z squared is 5z. Again, if I squared that, I would get 25z squared. And if I squared that, I would get 9x to the 4th. And then I check my multiplication of those two and I double it. So 3x squared times 5z is 15x squared z. And then I double it. And because I do get the same value that's in the middle, I know it fits my perfect square trinomial pattern because it fits this pattern. Now this one has a minus. So again, that's the only difference, which means when I write it, it's going to be minus. So it would be 3x squared minus 5z quantity squared would be my factorization. Again, I certainly could do that using the tic-tac-toe method. This is actually a little bit easier. Let's look at our next one. The square root of 4x squared is 2x, because 2x squared would give me 4x squared, and the square root of 25 is 5, because if I squared 5, I would get 25. If I multiply 2x and 5, I get 10, and if I double it, I get 20x. Notice this is 10x. So this is not the pattern. That's not to say that we couldn't factor it, but we're just trying to see if it will factor using this perfect square trinomial pattern. So in order to factor it, I would have to check if 4 times 25, which is 100, if I have factors of that add to 10, and they don't, so it's not factorable. Here are two for you to try on your own, so give them a shot and then press play to see how you did. For my first, I would say the square root is 2x, and here the square root is 9y, and then I would multiply those together and double it. So if I multiply them together, I get 18, I double it to get 36 xy, and it does fit my pattern. So I'm going to subtract my terms to x minus 9y quantity squared. For my second example, the square root of x squared is x. The square root of 1 is 1. If I multiply those together, I get x. If I double it, I get 2x. That doesn't fit the pattern, so not factorable.